Okay, these are the 9.5 notes, solving trigonometric equations, page 8. Pretty straightforward here. Last page is not going to take us a ton of time. There is one thing I want to point out. These problems are asking for answers in terms of degrees. So make sure your calculator is set to degrees as you move forward in these. Okay. And so, as with any word problem, primary concern is making sure we understand what's being asked. So I'm going to start by drawing a picture. So we got an airplane. Here's my airplane. There we go. Only has enough fuel to fly to a city 200 miles northeast of its current location. So this is north. This is east. And so northeast is going to be somewhere over here. And so we've got 200 miles northeast. The pilot knows that the city is 25 miles north, so we're going up here 25 miles. My picture is definitely not in proportion, but that's okay as long as they're drawn so that I can make sense of how the sides of the triangle are labeled. So let's see. The pilot knows the city is 25 miles north. How many degrees north of east should the plane fly? So now here is the issue here. North of east. This is the angle we're looking for right here. Okay. So because I'm talking about right triangles, I really could just drop this side here. It's going to be the same as the other side. I mean, it's, you know, that right triangle is going to be half of a rectangle. And so if I'm trying to find x, I have the opposite side. I have the hypotenuse. And so I'm going to use sine. Sine of x equals the length of the opposite side over the length of the hypotenuse. So the inverse sine, and I could reduce that to 1/8, but I could just plug it into the calculator this way. And I get 7.18 degrees. We want to make sure to label that so we know we're talking about degrees and not radians. Okay. Example 19. A woman is watching a launched rocket, currently 11 miles in altitude. So let's go. Here's my 11 miles. Here's my rocket. Good enough. And she is 4 miles away. Now, realistically, as I draw her, you know, I'm going to draw the triangle from her feet. If she's 4 miles away from her feet, from her eyeballs, it is not going to be much different. Don't get really hung up in exactly where her eyes are, how tall she is. We're just kind of using the numbers that we have as sides of a triangle. Okay. And so we're looking for what angle she's looking up from the horizontal. So we're looking for this angle right here. We have the opposite side and the adjacent side. So the tangent of x equals opposite over adjacent. Inverse tangent of that 11 over 4 should give us x. And we get an angle of 70.02 degrees. So example 20, a person does a handstand. And I will tell you, as a former gymnast, this one bothered me just a little. But we're okay. So here's our handstand. Here's his head, here's his arms, here's his feet. He's 6 feet tall. We're going to assume that's with arms outstretched. His hands are 1.5 feet away from the wall. And let's figure out what it is we're looking for. We want what angle his feet make with the wall. That's this angle right here. So that is the angle that we are looking for. We have the opposite side. We have the hypotenuse, and so again, we are talking about the sine. The sine of x here, 1.5 over 6. So inverse sine of, we could reduce that to 1/4 or just plug it in this way. And we get 14.48 degrees. They don't ask for specifically, I mean, radians or degrees. Go with degrees, unless we're talking about a straight line measurement. And that's it for the 9.5 notes.